Hello and welcome back. In this episode we're going to create a Flutter application. We're going to register that application as a client in our identity server. We're then going to sign the user into that application, obtain an access token and use that to send an authenticated request to our API. So in our identity server project, open up the program class and you'll notice that we've got the configuration DB context from our dependency injection container. And what we're going to want to do is we're going to want to register our Flutter application. So we can say configuration DB context.client.add. We can say new client like so, and then .to entity. And then within our client, new client, we can paste in our client configuration. So we're giving it a client ID of Flutter. Again, feel free to use a GUID or other unique identifier for each of your clients. We've then got allowed grant types set to grant types code because we're going to be using the authorization code flow with PKCE. Require client secret is set to false because this is a native application. The client secret cannot be securely stored in the source code because anybody could decompile the source code of the application and extract the client secret. So we are not going to require a client secret for our Flutter application. Allow offline access is set to true. This will return a refresh token with our access token, and we can then use that refresh token to automatically refresh access tokens as and when they expire. And that means the user doesn't have to keep signing in every time the access token expires. You can see we've got a redirect URI and post logout redirect URI of com.example.myapp://callback. That com.example.myapp is generally the reverse domain name of whatever your application is registered as. In this case, just com.example.myapp, but feel free to change that to suit your requirements. And then simply call back just any arbitrary path. I've called it callback. You could call it OAuth redirect, OpenID connect callback, whatever you like. But it's important just to make a note of this redirect URI because we will be using it a little later on. And then last but not least, in our allowed scopes, we have the OpenID scope to sign the user in and obtain their unique user ID. We've then got the profile scope, which allows us to get the user's basic profile data, such as first name, last name, etc. And the offline access scope then allows us to get a refresh token back with our access token that we can then use to silently refresh the access tokens when they expire. And then we've got the API scope, which is the scope that we've created for our API. If you've created scopes like maybe read, write, etc., then make sure you add the appropriate API scopes here in the list of allowed scopes for the Flutter client application. And then last but not least, we simply do configuration DB context.save changes. If we then select identity server from our run configurations, and if we then run that identity server like so, this will then add that client into our identity server database and open up our identity server application like so. If we pop into our database, open up the clients table, you can see here at the bottom we have our Flutter client created in the database. So what we can do, we can minimize that and we can get rid of this client configuration now that that is registered for us. And we can jump into our Flutter application. So what I've done for that is inside IntelliJ, I've created just a brand new blank application called MyApp. Inside the main.dart, you can see we've got the standard file new Flutter application. I've slightly modified the homepage to simply just have a centered text of hello world in the body rather than the default counter, because we'll be replacing this in a minute anyway with our weather forecasts. And then I've also gone on ahead and created a weather forecast model with the JSON serializable package. So this will be able to then deserialize our weather forecast from JSON from the API into a weather forecast model that we can then show in the application itself. So with this all set up, we can work on adding in our authentication. And to do this, we're going to be using the OAuth2 package. So you can see here, OAuth2 is a client library for authenticating with a remote service via OAuth2 on behalf of a user and then making authorized HTTP requests with the user's OAuth2 credentials. So what we can do with this OAuth2 package is essentially use it to handle the entire authorization code flow for us and without us having to write any of that logic ourselves. So we're going to be using the OAuth2 package. We're also going to be using the URL launcher package because the OAuth2 package will give us a redirect URL, and from that redirect URL that we specify, the OAuth2 package gives us this authorization URL, and we can then redirect the user to that authorization URL for them to sign in the identity server. So this authorization URL will point to our identity server, and we can essentially use the URL launcher to launch that URL for the user to sign in via their web browser on their device. We're then going to use the Unilinks package to listen to the redirect back from IdentityServer. That will be in the form of a deep link for this episode, and essentially we're going to register that deep link in our Android manifest, and then we're going to listen for redirects to come back from the IdentityServer into our application. We will then essentially latch on to that link, extract the appropriate parameters from the query string, because things like the authorization code, state, etc., that's all returned as query string parameters in that redirect URI. So we can use Unilinks to extract those query parameters from the URI that we get back in our redirect from IdentityServer. So what we're going to do here is, first and foremost, is set up the OAuth2 package. So once we've got that installed, we can come into here and we can make a note of the authorization endpoint and the token endpoint. So if we pop into here and we can say authorization endpoint, and we're going to put in the URLs to our authorization endpoint and our token endpoint. Now you're probably thinking, at the moment, our identity server is running on localhost. However, we're going to be running our app on the Android emulator. And of course, the Android emulator's localhost is not the same localhost as our machine's localhost. So what we're going to do is we're going to use a tool called Ngrok, which will allow us to create a secure tunnel from our local host out to the internet, which we can then connect from the Android emulator. So once you've got Ngrok installed on your machine, we're going to come down into our identity server solution, and inside the terminal here, we're going to say Ngrok HTTP, and then we're going to say HTTPS localhost port 5001. And we can see here, we then have that localhost 5001 running on this secure tunnel here. So if we click that, you can see we get directed to our localhost running identity server. And if we open up our discovery document, like so, you'll notice that we have the authorization endpoint and we have the token endpoint. So if we copy that authorization endpoint, first of all, into the authorization endpoint just there, and if we then pop back into here and make a note of the token endpoint like so, and paste that into the token endpoint, you can see there we have then our authorization endpoint and our token endpoint created. If we then pop back into the OAuth2 package documentation, you can see we add our client ID as the identifier property. So we can then come into here and we can say final identifier equals, and we called it Flutter. Again, if you used a GUID or some other unique identifier, then make sure you put the correct client ID here in this identifier property. Coming back over to OAuth, we did not set up a client secret because this is just a public native application where the source code is readily available to be decompiled by the end user. So we'll ignore the client secret, but what we will add is this redirect URL. And if we pop that in, this is the redirect URL that we configured in IdentityServer earlier on that I mentioned to make a note of. And that was, in our case, com.example.myapp : and then callback, like so. Again, if you have a different reverse domain notation there, feel free to update that with whatever redirect URL you used in the identity server as the redirect URI. And much the same with the path. If you gave the path a different name, then make sure this matches exactly what we registered in IdentityServer. So if we pop back into the old tune, you can see here that it stores the credentials as a file in order for the credentials to be persisted between sessions. So that allows the refresh token to be stored between sessions. So if the user closes the app and then reopens it at a later date, then, as I say, it will get that refresh token from the persisted credentials, use that to obtain a new access token without the user having to sign in. And we won't worry about that for the purposes of this demonstration, but that's just one of the ways that you can persist that refresh token between application sessions. What we will do, however, is we will copy this create client method like so. If we pop back into here, and at the top we can say create client like so, and you'll notice here that we have a missing dependency on that OAuth2. So we can import that package like so, import package OAuth2 as OAuth2 like so, and that will get rid of all of these little red squiggles for us. We can get rid of this logic to check if that file exists or not. Again, feel free to persist those credentials, but we won't cover that for this episode. What we can then do is we can come down into this grant, and you'll notice we have identifier, authorization endpoint, and the token endpoint. We don't have a secret, so we can get rid of that property like so, and just leave it as our client ID, authorization endpoint, and token endpoint. Next up, we have our authorization URL, and you can see here that we can optionally pass in a list of scopes. So what we can do after this is we can say scopes, and this is going to be a list of scopes that we registered with our identity server in that list of allowed scopes. So what we can do, we can say OpenID, we can say profile, we can say offline access in order to get that refresh token, and then we can say API. Again, if you created different scopes for your API, for example, read, write, etc., make sure this list essentially matches the allowed scopes that we are allowed to request from the identity server. And then if we come down, we can implement the redirect method and also the listen method, like so. So what we're going to want to do first of all is handle the redirect, and this is what's going to redirect us off to the identity server to prompt the user to sign in. So what we can do is we can say future void, and then we can say redirect with a URI of authorization URL like so. This will be an asynchronous method, and we can say if await and can launch. We'll check to see if we can actually launch the URL first and foremost. So that will be .toString like so. And if we have the capability to launch that URL, then we can simply say await, and then we can say launch, and then that authorization URL .toString like so. And else we will just throw an exception. Again, you'd probably handle this in your application a little bit more gracefully than just throwing an exception, but we can say unable to launch authorization URL like so. So what this will do is it will check to see if we can actually launch that URL. For example, if for some reason the user doesn't have a browser installed on their device, then obviously we won't be able to launch, the HTTPS URL. So it does that check, and if it's able to be launched, then it will launch it, and if not, then it will just throw an exception saying, hey, I couldn't launch it. You need to sort it out, basically. So that's the redirect method, and we'll now move on to do the listen method. So this redirect is using the URL launcher package, and the listen method is going to use the unilinks package. So if we pop back over into here and open up the unilinks package documentation, we can see in Android we need to configure our deep link. So what we can do, inside our manifest application activity, we can add the deep link as an intent filter. So if we pop back into IntelliJ, in the Android folder, app source, we have an Android manifest file, and inside here we have manifest application activity, and you can see down here we have our intent filter. So you can see here that we have our Android scheme, which is com.example.myapp. This scheme part will match the first part of the redirect URL, this here, com.example.myapp. Make sure that these two values both match. And the host is then callback, which is the second part. Again, you need to make sure that both of these match, callback there and callback there. So as I say, these values should both match one and each other, and they should also then match what we set up in IdentityServer at the beginning when we registered the client. So if we scroll down now, we can start work on implementing this listen method now that we've set up our intent filter for the redirect URL. So if we put back into our main.dart and we can say future of type URI, and this will be a nullable URI, by the way. We can say listen, and this will be a URI of redirect URL like so. It's going to be asynchronous, and let's fix that typo there like so. We can say return await, and if we pop back into the Unilinks documentation, you can see that we have a usage for initial link as a URI and on change event as a URI. Now the initial link URI will get fired when the application launches very early on in its life cycle, and then it won't be fired again after that point. So if the application wasn't already running, then we would want to use this initial link method. However, because the application will already be running in the background when they sign in, we want to use this on change event URI because it will be a change event that will be coming back into the app because the app will already be running. So initial link won't be any good because it will have already fired long before we've actually signed into the application. But that's just a bit of a gotcha there. If you don't have the application running when you log the user in, then you want to use this initial link rather than the on change event. But for most use cases, the on change event should suffice. So you can see here we have this URI link stream property. So if we pop back into here, we can say URI link stream, import that library up top, and we can then say first where, like so. And we can say element dot toString dot starts with, and we can then say our redirect URL dot toString. And what that will basically do is it will basically check to see the first URL in this stream that starts with our redirect URL. That's because this listen method could, it's just a stream of links that come into the application. So there could be a link that is unrelated to authentication, comes in, just so happens to come into the application whilst we're signing in. Obviously, we don't want to handle that as part of our authentication flow because that would cause it to crash when it tries to then handle that response. So what we can do inside this URI link stream.firstWhere, we're basically converting that URL to string, and then we're checking to see if it starts with our redirect URL that we defined up here like so. That's because when we get the redirect back from IdentityServer, it will attach the response as query parameters. So it will be, for example, code, state, etc. will all be attached as a query string on the end of this redirect URL. So com.example.myapp : // callback ? Code equals blah, and so on and so forth. So what we're doing there is just basically checking to see, does the URL in the stream start with the redirect URL? If it does, perfect, that's the one that we want. If it doesn't, then just ignore it because it's irrelevant for the authentication flow. So with this set up like so, you'll see that there is going to complain because it's can potentially be null because of this nullable on there like so. So what we just do is we say if response URL equals to null, then we will simply throw an exception, and we just say response URL was null, like so. And that will then handle the edge case. Oh, of course, you want to do this gracefully in your application, especially in a production environment, but that will just crash out saying the response URL is null. So what we can then do, now that we have this set up, is we can actually do some logic in our home page to go off and sign into the application. So within our home page, we have this late future ready to go at the top. And what we're going to want to do now is we're going to want to override the init state method. We can say super.initState like so. And then we can say future equals create client. And we can then say .then. And inside here, we can do some logic to essentially go off and use that authenticated client to make a request to our product API. So what we're going to do is we're going to create another method just below all of our authentication. And we're going to be, it's going to be a future, and it's going to be a list of weather forecasts that it's going to return. And we're going to just call this get weather forecasts, like so. And this will take in our authenticated client, like so, and it's going to be asynchronous. And inside here, we can then get our list of weather forecasts. You can see that red squiggle there because it's not got a return statement yet. So what we will do is we can say return, and we can say await client.get, and that will be our URL to our API. Of course, that is also going to be running on localhost, and so what we're going to want to do after we've signed in, we are then going to want to switch our Ngrok from IdentityServer to the API, so we can then call the API via Ngrok and use that to get our list of weather forecasts. So for now, I'll just pop the path of weather forecast in there like so. And then what we can do is we can say simply just var response equals, and I can make that final. That will go off, get our list of weather forecasts, and we can then say return JSON dot, and if I do import that like so, JSON dot decode our response dot body, and that will be as a list, and we can then essentially map each one of those to our weather forecast from JSON, and on the end then just to list like so. And that will essentially then get the response from our API. It will then decode that into a list, and then convert each one of those list items into a weather forecast model using that weather forecast dot from JSON, courtesy of the JSON serialization packages. So now that this is set up like so, we can come back down into here, and we can then say get weather forecasts, and we can pass in the client. And this will then give us our list of weather forecasts inside this future. So what we can then do inside our body is we can create a new future builder. It's going to be of type list and weather forecast, like so. And this future builder will take a future argument, which is going to be our future. And we're then going to have the builder, which is going to be a context and a snapshot. And what we can do in here is we can say snapshot.hasData. Then we can return, for now I'll just pop a center widget in there. If we don't have any data, then we can center with a child of circular progress indicator, like so, just to return a loading indicator if we don't have any data. What we can then do inside here is replace that with a list view.builder, and the item builder is going to return us a list tile, like so. And the list title is then going to have a title, which will have some text. If I just save that to format it. And this is going to be a snapshot.data with index and then dot summary inside that text. And last but not least, the item count is going to be snapshot.data.length, like so. You'll notice these are giving us a bit of a grumble because that data, snapshot.data, could be null. However, we verified this snapshot.hasData is true, so we can simply pop the bang operator in there like so, because we know that's not going to be null if it has data. And then what we can do here, because summary is a nullable string, as we see down here in our model, it's nullable. So we can simply just say if there isn't a summary, then just an empty string, like so. So that will go off to our create client method, which will ask the user to sign in. Then it will use that client to go off and get the list of weather forecasts. So what we can do, now that we have this up and running, if I pop a breakpoint just on there like so, and if we now debug our Flutter application, and we should then be able to sign the user in and get an access token with an authenticated OAuth 2 client. So if I flick open the emulator like so, give it a few minutes just to compile and build the application for the first time. It takes a few moments on the very first build, much quicker on subsequent builds though. And we can see here we have our application running like so. Home page loaded briefly there, and we were redirected off to the identity server. You can see here we have our login screen. So I'm going to pop in the test@example.com, which is our username that we created in the ASP.NET Identity database previously. The password we can then pop in like so. If we then hit login, we're now being returned there back to the application, as you can see. And we now hit our get weather forecast method with an OAuth 2 client. And you can see the identifier there, Flutter, our null client secret because we didn't provide one. And we can see here that we have our credentials object. And you can see here we have an access token, a refresh token, and an ID token. So as I said earlier, that refresh token can be used to refresh the access token automatically and silently in the background when the access token expires. And that is something that the OAuth 2 client does for us automatically. We don't have to worry about that refresh process. And of course, what we can then do once we have signed the user in to the identity server is we would then update the URL here of the weather forecast endpoint with the Ngrok URL for the API. The limitation with the free plan of Ngrok, unfortunately, is that you can only have one URL being sort of tunneled at a time. So obviously we set the authorization endpoint and the token endpoint to essentially be behind that Ngrok secure tunnel. That does mean, of course, unfortunately, that we can't then use a tunnel to our localhost API. If you have one of the paid plans for Ngrok, then you'll be able to have multiple tunnels running. So that's essentially showing you how you can set up a Flutter application with the localhost identity server using Ngrok to create a secure tunnel from the essentially Android emulator, the internet, into the localhost identity server. So what we've done in Identity Server is we've registered the Flutter application as a client. We've then come into our Flutter application and used the OAuth 2 package, the Unilinks package, and the URL launcher package to handle the authentication flow. We used the OAuth 2 package to create an authenticated client using our client ID, the authorization and token endpoints, our redirect URL, and our list of scopes. We've then used the URL launcher package to handle the redirect off to Identity Server to prompt the user to sign in. And we've then used the Unilinks package to listen to the callback from Identity Server to extract all of the relevant query parameters from that response back from Identity Server. And we've then used that created client to then send an authenticated request to the weather forecast endpoint inside our API. And we then just have a simple list view widget to render the list of summaries, as I say, as a list view on the page. So I hope you found this episode useful. Thank you very much for watching, and I'll see you next time.